An active weather pattern continues. A couple of key areas of interest: this large area of so-called overrunning across Texas, Arkansas, and the Mississippi River Valley, and a strong system moving through the Rockies this afternoon. Here's the surface chart showing a strong Pacific system moving through the Four Corners region, but ahead of it, there has been a large push of cold Canadian air into much of the eastern U.S. Temperatures are down into the single digits from Nebraska up to Minnesota, and of course, further south we've got this area of snow and extensive freezing rain. The freezing rain focused mostly on the Interstate 30 corridor into Arkansas. And down at the bottom, a strong contrast in the air mass, 34 at San Antonio versus 80 at Brownsville. The frontal zone, supported by the thickness lines, the strong gradient, that goes from California across the southern U.S. into the northeastern states, but we can see the strongest gradient located around New York, New Hampshire, Vermont, as well as down in Arizona. So that's a very potent system. Let's take a look at the upper levels. This is where we're at right now. If you remember Monday's video, you recall that we had that trough going into the base of a larger trough, and that tends to amplify it. And that's going to be the major shortwave right there in Southern California. Ahead of it, an extensive area of lift. And that's from the Four Corners area across Arizona and down into the northern Gulf of California. And then on the backside, some strong subsidence. Now you might think that would clear out the air mass, but we've also got cold air advection sweeping in. That tends to destabilize the lower atmosphere, and as a result, we do have some snow showers in the mountains around Los Angeles. Further out to the east, we have this lead shortwave. That's got an area of upward motion in eastern Colorado, and the panhandles. Looks like another wave even further to the east, approaching Illinois, and then, of course, this major one in the northeastern U.S., supporting the occlusion and the triple point along the east coast. The water vapor imagery explains a lot of the misery affecting the U.S. One is going to be this atmospheric river coming into Texas. That's bringing up moisture from the tropical regions. And also, hanging back across the southern Rockies, that's going to be that other system that we discussed. The main polar front is well to the south, but still quite a bit of instability north of that triple point. And of course, here, the dominant process is isentropic lift. The integrated water vapor plot does show a somewhat more complex picture. The basic axis of the atmospheric river, or Pineapple Express, runs about like that. However, lots of tropical air associated with that. It's being picked up and advected into that southerly flow. So some of the high-level tropospheric moisture originating from the southwestern regions of Mexico and much of the low-level moisture coming from the Caribbean and Western Gulf. The integrated vapor transport map does seem to confirm that. Most of the emphasis is on the tropical moisture coming up from the Gulf and not so much from the western regions. And part of that is due to the presence of the plateau region of Mexico and the fact that there's just not a great depth of moisture out to the west. It is pretty interesting to go into northern Mexico and look at the air masses. Here at Chihuahua, 73 degrees with a rather dry dew point. And as we go further to the northwest, we pick up the frontal boundary. Northeast flow in the Big Bend, and as we move northeast, we get into progressively colder air, 20s out there in the hill country. And then we go further out to the east, and we start picking up some of that freezing rain, snow, associated with that rich southerly flow off the Gulf, even more of it in Arkansas. So let's take a look at a sounding, say for Shreveport. We see a very shallow northeasterly flow. That northerly component only goes up to about half a kilometer. So it's only up to about 1,500 feet. If you were on top of a 3,000-foot tower, for example, you would have a slight southerly wind. And the temperatures at that level would be a lot warmer than close to the ground. In fact, up at 5,000 feet, look at that, we've got over 50 degrees at 5,000 feet with a wind out of the southwest at 30 knots. So this is clearly a very shallow cold air mass with extensive overrunning just above the frontal transition zone. And that is the key ingredient in major ice storms, especially in the eastern half of the U.S. Taking a look out into the Pacific, looks pretty good this afternoon. Of course, the usual culprits in Alaska, wound up occlusion, a very extensive nose of warm air, temperatures coming up into the mid-30s across much of Alaska, which is quite warm for this time of year. And that's pushed a lot of the colder air up to the North Slope and into Siberia. Further out to the east in Canada, looks like there's been some moderation to the cold temperatures. We've got 21 west of Yellowknife, 27. That's quite warm, so they've got some downslope working on that part of the continent. And very likely there's been some mid-level warming to assist with that as well. Much of the colder air has been pushed out to the east over Baffin Island. Looking out into the Atlantic, stormy around Iceland. They had that major system a couple of days ago. And then dropping south, we get to that active occlusion across the Canadian Maritimes, and we pick up the warm sector off of Maine. And this afternoon, 64 at Bangor. And a little further south, 60s and almost 70 degrees around New York. So the warm air is close at hand, but you go out to the west, and it does rapidly get much colder. So, what a great opportunity to do isentropic plots. We're going to do that with cross sections, and we're going to construct a chart that's somewhat parallel with the mid-level winds. So something like that, because in the mid-levels, the winds are coming out of the south-southwest. So let's set up a chart going from south of Laredo up to Little Rock. So what we're going to do is we're going to look at cross sections. A good place to get that is from weathernerds.org. So I've got the GFS model here. I'm going to bring that up to the current time, update that, go into cross-section mode, and I like to set the first point up to the north. So that always orients me so the north is to the left and the south is to the right. So there we go. Got that set up. Go to Get Cross-Section, and let's see what we got. So we confirm that with that inset down here. Yeah, that's A to B, which is, A to B. And there it is. There's the top of that cold air mass right there. The color coding is the wind speed. So we see the jet right there, right up on top of the frontal zone where we would expect that. And so we can look at this and get an idea of the slope of the cold air. So out across northern Mexico, it tops out at about 850 millibars, which is about 5,000 feet, and then gets a little bit higher as we get into Missouri. It gets up to about 7,000 or 8,000 feet, maybe 9. Now, don't forget these model fields. These are interesting. One thing you can use is moisture. You can click any of these here. It'll produce the same output. And we can see the saturated air under 8,000 feet in that transition zone and down in the cold air. And as well, we have some altostratus cirrus from dynamic lift in the upper troposphere. Now you notice we don't have any wind data here, so really to get that isentropic lift, we need to have ascent. Air tends to cling to these isentropes, these black lines. So if you set it moving from B to A, that's assuming the air is moving right to left, it should cling to these lines here, and that would suggest upward motion within and below the frontal transition zone. So if we click on winds, we don't really get any actual wind data. All we have here is the absolute values of speed. We don't know which way it's going, and that's the reason we have to use isentropic plots. And for some reason, that's very difficult to find on the internet. College of DuPage, they do have it, a very limited subset, but that's going to be under analysis data. On the left here, you have isentropic maps. Here we have the 294 Kelvin map, and that's probably about where we want to be. An incorrect level, I'm going to click on one right there. If you go up into these warm values here, that's up at 600 millibars. See these little numbers right here. That's up above 10,000 feet. We're not really concerned with that, so we need to drop down to lower values. And there you can see the higher relative humidity popping up. This is about 850 millibars. That's about perfect. And we see that flow up. And as the wind flow moves south to north, it gets into these progressively lower millibar values, which means ascent. Because 650 millibars, that's up at about 14,000 feet. 500 millibars, that's going to be up near 18,000 feet. So as we come up from the south, we start near the surface and we ascend up to about 10,000 feet. So lots of moisture, lots of lift. That's isentropic lift. Now, if you want to get into some more technical cross-sections, tropical tidbits, they've got a nice model plotting engine as well. And the way that works is with control and drag. So I hit control, hold it down, and I drag across that same area. And I got this pop-up box down here. And you notice that we have the choice of normal or in-plane wind. So that does give you wind plots. I'm going to do in-plane. So the in-plane wind, that's going to be the component of wind along the cross-section. So we're looking at only the south-southwest to north-northeast component. This is suggesting we have a very strong right-to-left flow. So certainly right there, about 5 to 10,000 feet, a component of motion like that that's given us some ascent. And since that layer is very moist, that's what's given us this rain, clouds, and freezing rain. Now, if we go down here and click on normal wind, that's going to be the component going across the cross-section, so west-northwest to east-southeast. And that outlines the jet being much stronger up to the north and diminishes as you go south. And you notice this area right here, which has no dashed lines, that's flow coming out of the page. In other words, that's going to be right here, flowing this way. And that's going to correspond to this area of shallow easterly flow in West Texas. Now, we do have a very dynamic weather pattern this afternoon. Very strong cold front in Arizona. Strong winds out ahead of it. Gusts over 50 at Truth or Consequences and Deming, New Mexico. And then this warm front coming down through far east or far west Texas. Also canyon winds developing. Albuquerque, east at 20. We're going to do a transect from, say, Las Vegas across that zone and towards Lubbock. So there's B, and here's A. Now a good product for that is the 3-kilometer NAM. And already we do see elements of what's happening out there. Strong cold front, The warm front, that's it right there. And let's go ahead and do that transect. We're going to run about somewhat like that. So in-plane wind, that'll give us the west versus east motion. And there it is, the easterly flow through the canyons. Albuquerque located right here. And you can see the top of that cold air mass, quite shallow, only up to about 800 millibars. Up above that, the warm air. And then we catch a little bit of that Pacific front kind of in here. And you notice that there's kind of like this folding shape right there. Let's go over to potential vorticity. We can use potential vorticity as a tracer in the vertical of air mass origin. So here we've got stratospheric air being pushed downward. That's going to be subsidence. And then on the other side, we've got ascent going on. And right here around Gallup, the continental divide, we've got a troposphere fold. So some very strong vertical motion taking place right there, indicating a cell somewhat like that. Remember, we're looking at a cross-section from Las Vegas to Lubbock. And meanwhile, out to the east, there's the top of the cold air mass. The potential vorticity does reveal that. So it's a pretty neat product. And yeah, you should definitely check that out. In fact, I think this may somewhat outline the Pacific front, maybe something like that right there. Okay, hopefully I did not put anybody to sleep. I find those tools very useful and exciting. Let's take a look at the records. These are the forecast highs for today. You can see 68 there in Massachusetts, 66 at Portland. Those are breaking records for the date by about 5 degrees. Also a very warm day in South Carolina and Georgia, up to 83 at Macon, breaking the record set in 1980. And here's the records for tomorrow. Definitely looks like slow going for that front in the southeastern U.S. 85 for tomorrow in Georgia. Meanwhile, out west, a cold morning, 27 at Sacramento. We're looking at 41 in Los Angeles, 38 at Long Beach, and all of these are breaking records for the date. Wow, 17 minutes in and we have not gotten to the forecast. So let's do that. This afternoon, there goes that area of precipitation moving rapidly. The rapid motion suggesting it's embedded with vertical motion in the mid-troposphere. You can see by 0Z, it's already moving into Kentucky. However, more weather coming from the west. Look at that, another area developing around DFW overnight, around 3 in the morning. That moves into the same area of Arkansas, Missouri for tomorrow morning, and up into the Midwest for tomorrow afternoon. And that's probably the last big shot of moisture in the Central Plains. Everything moves out to the east by Friday and Saturday, and looks like a snowstorm for parts of the northeastern U.S. and some mixed phase precip around New York and Philadelphia. Then it's a cold weekend, not much going on. This is a classic prevailing high. All of this is high pressure. So down in the Gulf, offshore flow, cold in northern Mexico. And meanwhile, a little bit of downslope setting up in Montana that may moderate the temperatures a bit. And up to the north, a new outbreak of cold air, but this is heading mostly into Quebec and Ontario. And then just running that forward, a little bit of instability down there in the Gulf. A few storms, but most of that's going to be elevated. Another Alberta Clipper moving south around Monday or Tuesday. Not much strength to that. There it goes. Affecting mostly Pennsylvania, New Jersey. Classic PNA pattern. And then around March 3rd, March 4th, late next week, looks like a strong downslope pattern in the Great Plains. So it looks pretty warm in the central U.S. Continued cold in the northeastern states, and cool and unsettled in the Pacific Northwest. We are running a little bit late, but I did want to make a stop here and look at the highly dynamic weather in New Mexico. Remember, we had a cold front running about like that. Warm front back against these mountains here, and We were starting to get that canyon wind in Albuquerque. One thing I'm surprised about is there's not really much upslope stratus and fog. That tends to be very common in this kind of pattern, but appears we have quite a bit of dry air advection that has prevented that from happening. But yeah, very cold temperatures up to the north. Meanwhile, out to the west, convection, that's a classic antifront setup. Back behind the cold front, very strong lift. And in between, very strong southwesterly winds, picking up that dust off the playas in parts of Arizona, Wilcox, Deming, and even White Sands. And it looks to me like White Sands is getting south-southeast flow. So they're probably just behind that front, getting some flow about like that. Meanwhile, on the other side of the front, pure southwest flow. And there it is, one more time on the surface map. And we're going to check in with Big Rig Steve. He's way back behind that cold front. Around Truckee, California, he's going from Denver to the west coast, passing through the mountains. Looks like a very degraded picture. Cell phone reception not so great, but this is looking west. Still a little bit of instability in the lower levels, cold air advection cumulus, and some of that is due to heating on the terrain. Just enough cold air in the mid-levels, just enough heating off of some of these slopes, and we get that cumulus developing. Well, so much for that stream. Let's take a quick look at the weather in Ukraine, since that's very much in the news right now. A lot of concern this week about a possible war. Looking at stagnant conditions, for the most part, temperatures in the 30s and down in the 40s along the coast. But as you go out to the west, looks like a little mid-level system traversing the area, some instability, producing some rain showers. And what we're going to focus on over the next few days is going to be this front. For one, you can see some major impacts in the British Isles and Norway. That's going to move mostly to the east and north of Belarus and Ukraine. However, as the tail end passes the Mediterranean, we're going to see increasing flow through that region. Looks like cyclogenesis, and that'll move across Italy into Greece. And the net effect of that is it heads into Turkey, stormy in Turkey, and we will have some northerly flow start to develop across Ukraine that will cool things down for early next week, maybe bring the temperatures a little bit below freezing. But overall, not really any major weather expected. In closing, I want to thank our newest Patreon supporter, Nathan Bergeron. Thank you very much for your support. And Thomas Wozencraft sent a nice note. He said, your hard work and passion for teaching meteorology is widely noticed. You bring such a high level of understanding that is far beyond the common TV gal or dude. Those who have an education in weather see your expertise. Please continue the work. It is noticed. I appreciate the comments, Thomas, and we'll try to keep going with this as long as we can. Hope everybody has a great Wednesday evening, a great Thursday, and we'll see you back here on Friday. Have a great one. Bye-bye.